Hi everybody, this is Mr. Nolan, and what I would like to do with you in this video is talk about Michigan's iron resources. In Michigan's UP, we have a lot of iron resources. They're very valuable, and I want to make sure that you understand where the iron came from and what kinds of things were going on the planet when the iron was deposited. Now, I'm going to mention a little bit about copper, but the focus of this video is really on iron. It has really basically defined the Western Peninsula. There's places, like Iron Mountain and Ironwood, and there's the names of all kinds of places over here that have iron in the name because that was really influential in Michigan's economic history or economic development. It's also kind of related to the auto industry, that because Michigan had so much iron to make steel, it really put us in a great position to manufacture vehicles. So this is important to our history as a state. So to understand where iron came from in the UP, you have to kind of be patient and buckle up for kind of a complicated ride. In case this video, if you walk away from this and you're still confused, I've linked another video, probably a better one, in the information section of this video, so you can watch that, and that will kind of maybe do a better job of explaining what I'm going to explain to you right now. So let's first look at the types of rock that we find in the UP. So if we zoom in a little bit to the UP, this is the Keweenaw Peninsula, this kind of horn sort of jutting off. Down here, we find the very upper edges of these special ring structures that we saw in Michigan. If you remember, Michigan has these circular sort of ring structures in the lower peninsula. If we look at the upper peninsula, these are just the very edges of those rocks. These are sedimentary rocks. Just about any time that you find these really nice organized layers, these are probably sedimentary. They're laid down one on top of the other, basically horizontally, and so they form these really nice, pretty kind of straight sort of layers. But if we go over here to the western UP, this is metamorphic stuff. So all this this pink, this is all metamorphic, and that means it was squished. It was squished and squashed. So there's probably tectonics going on that created these rocks, and so they were metamorphosized. They were squished. We also have a big long line of igneous rocks right here. These sort of pale orange colored rocks are the Portage Lake volcanics, so each of these different colors has its own name. So like this really dark pink one is the Michigami group, and then we have the Portage Lake volcanics, and we have the Munising formation, and we have all these different types of rock. But big metamorphic blob of rocks, little skinny line of igneous that I'll talk about in another video. But the iron is really found here in these metamorphic rocks. So these little thin brown circles, these rings, are the iron formations. These are the outcrops of iron that we find. There's gobs all over Marquette. If we look kind of in the Menominee region down here, it's cut off a little bit, but we find some more. Over here, just on the Michigan-Wisconsin border, we find a bunch of iron-banded iron formations as well. And then the copper are up here. Notice the copper are associated with the igneous rocks, and the iron formations are associated with the metamorphic rocks. So why is this? Well, let's look at the ages. Let's kind of get a sense for how old these are. The very oldest rocks in Michigan are these metamorphic ones found in these sort of upland areas of the UP. These are about 2 billion years old. They're called Paleoproterozoic. They're really old. And they've experienced a lot of pushing and shoving and smooshing around over that long period of time. The rocks over here in the ring structures that we find, these really large ring structures in Michigan, these are quite a bit younger. So these are 500 million years old about. These are called Cambrian, and then we've got some Ordovician, Silurian rocks. But these are very old. These are 500 million years old. However, they pale in comparison to the age of these metamorphic rocks. These are 4 times as old as these these northern parts of the Michigan ring structure. And then we also find these Portage Lake volcanics. These are not as old as these 2 billion year old metamorphic rocks. These are only 1.3 billion. So they're younger, right? So in order of appearance, we have these rocks, this big pink blobs of metamorphic rocks. Then we have these igneous rocks, and then after all that, we have these sedimentary rocks that form part of the Michigan ring structures. So if we look really carefully at these iron formations, they're all these little circles little circles and rings. And so we're going to talk about why they're shaped like that too. So if we go way, way, way back to the beginning, back in ancient times in Michigan's past, we really have to be thinking about what was the environment like at that time. So if we go to the UP and if we hang out in the areas where you're going to find these iron formations, you find these beautiful red shapes that we call banded iron formations. And these actually appear all over the world in 2-billion-year-old rocks. If you find banded iron formations, they're probably around 2 billion years old. So like, between 2.5 and maybe 1.8 billion years old is when we're going to find these banded iron formations. So they formed at a certain period of time and then they stopped because we don't find banded iron formations that are any younger than about 1.8 billion years. So these were around, these iron banded formations showed up long before this igneous line of igneous rocks showed up. So if we're hanging out in the UP, you might find some of these banded iron formations. These are some that are exposed at the bedrock. But this is kind of strange because we think that these rocks, these banded iron formations, actually used to be sedimentary. And the reason that we think that is because of how nice and straight these layers are. Even though they're squashed around, they really form these really nice contiguous layers, and then they got squashed. So we think that these used to be sedimentary rocks, which were then later squished in that metamorphism to form these kind of squish-squashed looking lines. This presents us a little bit of a problem, though, because if you have sedimentary rocks, that means you must have been underwater, right? If you were forming these nice layers of iron oxides and chert and all that stuff, these are sedimentary. However, there's a big problem here, and that is that iron will not dissolve in water, no matter how hard you try, as long as oxygen is around. So what does that mean? If we have a used to be sedimentary rock and it has tons of iron in it, that must mean that at one time when these were made, there was no oxygen around. So these rocks are so old that they predate oxygen in the atmosphere. Try to wrap your head around that these rocks are being laid down before there was ever oxygen in the air. This is pretty crazy. And so how could this be? How could there have not been oxygen at one time? And these layers were formed during that period. Well, probably the very earliest life on Earth, some of the very earliest life that was showing up at around this time or was starting to become active was a kind of bacteria that we now call cyanobacteria. This was some of the very earliest life. It's just greenish bacteria. It forms, pond scum. And what this bacteria does is it produces oxygen, lots of it. And so let me sort of diagram for this for you to kind of maybe make a little bit more sense if we diagram this a bit. So there was a time when there was lots of iron dissolved in the ocean. And to dissolve iron in water, it has to be basically an ion. It has to be charged as Fe2 or Fe3, so these are ions. And there was lots of iron dissolved in the ocean. This was possible because there was no oxygen. But cyanobacteria showed up, and these cyanobacteria began to produce oxygen. So they were performing photosynthesis. We can see our sun shining down, and these cyanobacteria produced oxygen. Now, when oxygen reacts with iron, that iron, if you've ever seen a nasty rusted out car, you know what happens when oxygen and iron interact in water. You get basically rust. You get these iron oxide minerals. So we have things like hematite and various iron minerals, and these will not dissolve in water, and they're kind of dense. So they fall to the bottom, and they form these layers of these iron minerals down on the bottom of the water. And the cyanobacteria is pumping out oxygen, it's pumping out oxygen, but the iron is basically eating up all that oxygen and then falling to the bottom. So the oxygen and the iron are getting all trapped down in the bottom of the ocean until the iron ran out. So that oxygen ate up all the iron and it fell down to the bottom. And so now we have this huge influx of oxygen up into the atmosphere. And that happened right at around the same time that these iron-banded formations had completed being created. So we have iron, cyanobacteria up here produce oxygen, and then that precipitates out the iron until there's no iron anymore. And now that's all just locked up in the bottom. So that's some of the really technical background that I kind of just threw at you really quickly. But what about these ring structures? Why does the iron formations form in these rings? Well, if you remember about the structures that we learned about in a previous video in modeling basins and domes. You'll remember that basins and domes will form rings. Just about any time that you find circles and rings, it means that you have basins and domes. And you can watch the video on that at another time. But basically what that indicates, to get lots of these little bases, rings and domes, there must have been metamorphism. We know that these rocks are metamorphic. Just look at them, right? You can tell they've been squished. So these rocks formed layers, the banded iron formations, and then they got squished. And so this axis of pressure, if we imagine the pressure squeezing together, maybe there were mountains being formed. We can, if you remember in the western UP, it's high elevation, there's lots of mountains there. During that mountain building, that squishing was probably what kind of folded these layers and gave us a bunch of domes and basins. And if you erode the top of a dome or a basin, you get rings, right? You get these ring structures. And so that should kind of come a long way to explain where did these rings of banded iron formations come from in the UP. They're basins and domes which were squashed, and they were formed as a result of this process going on in the ancient oceans before oxygen was really present in large amounts in the atmosphere. So to summarize, we used to have an oxygen-free atmosphere, and that allowed iron to dissolve and build up. But then we had algae show up on the scene, and these algae produced lots of oxygen, and that oxygen reacted with the iron. The iron fell out of the water and then was deposited on the ocean floor, and it formed those banded iron formations. You might see this abbreviated as BIFs once in a while, B-I-F. After that, we had metamorphism. Maybe, the tectonic plates were moving around, we have some mountain building, we have some, crazy stuff going on. And so that metamorphism folded and warped these banded iron formations, and the warping gave us domes and basins, small ones, right, kind of small, just a few miles across. And then even after that, erosion exposed those warped and folded layers, and so that gives us the appearance of rings, right? These layers are now exposed as what appear to be rings on the surface. So I hope that this video was at least a little helpful in helping you to explain the origins of the iron resources in Michigan's Upper Peninsula.